This is a video from section 9.3. The directions say to find the solution of the differential equation that satisfies the given initial condition. And so in these types of questions, we're looking for a very specific solution to a differential equation. And with that, we're going to take a look at problem number 13. Suppose we're given dy dx is equal to x e to the y. And the initial condition is y of 0 is equal to 0. So the solution to this differential equation must satisfy y of 0 is 0. And what does that mean? That means when x is 0, y is 0. Okay? Now, dy dx equals x e to the y can be rewritten as follows. We can say 1 over e to the y dy is the same as x dx. And so e to the negative y dy is the same as x dx. Well, we can integrate both sides. So the integral of e to the negative y dy is the same as the integral of x dx. And we're almost done. So negative e to the negative y is equal to 1/2 x squared plus c. Now we need to solve for c, and we're going to utilize our initial condition to do that. So remember, when x is 0, we know y is 0. And so negative e to the negative 0 is the same as 1/2 of 0 squared plus c. But that's going to tell me c is negative 1. And so negative e to the negative y is the same as 1/2 x squared minus 1. We need to be able to solve for y. So I'm going to multiply both sides by negative 1. And when I do that, I get e to the negative y is 1 minus 1/2 x squared. Okay. Now let's take the natural log of both sides. So natural log of e to the negative y is the same as natural log of 1 minus 1/2 x squared, which says negative y is natural log of 1 minus 1/2 x squared. And then either multiplying both sides by negative 1 or dividing both sides by negative 1, we get y equals negative natural log of 1 minus 1/2 x squared. And that's how we do problem number 13. Let's take a look at problem 17. Suppose we have du dt is equal to 2t plus secant squared t divided by 2u. And my initial condition says u of 0 is negative 5, which means when t is 0, u is negative 5. So this differential equation can be rewritten as follows. We can say 2u du is the same as 2t plus secant squared t dt. integrate both sides. So the integral of 2u du is the same as the integral of 2t plus secant squared t dt. So u squared is equal to t squared plus tangent t plus c. Now we need to be able to solve for c. So negative 5 raised to the second is 0 squared plus tangent of 0 plus c. But tangent of 0 is 0, so c is equal to 25. So u squared is t squared plus tangent t plus 25. Now, to get full credit, we have to solve for u. That's going to be the tricky part. Remember that u of 0 is equal to negative 5. So you have really two choices. Either u is the square root of t squared plus tangent t plus 25, or u is negative the square root of t squared plus tangent t plus 25. Now, I claim it can't be the first one. Why? Because what you're telling me is that if you replace t with 0, you're telling me that the square root of 25 would then equal negative 5, and that's not true. Square root of 25 is 5. It is not negative 5. So the first one cannot happen. And it turns out when you solve for u, you get negative the square root of t squared plus tangent t plus 25. And that's how you do problem number 17. If we take a look at 20, suppose dy dx is equal to x sine x divided by y. And it says y of 0 is negative 1. So when x is 0, y is negative 1. So x sine x dx is the same as y dy. So we want x's on one side, y's on the other. And I could integrate both sides. So x sine x dx, the integral of that, is the same as the integral of y dy. Now, on the left-hand side, we can integrate by parts. So I'm going to let u equal x, and I'm going to let dv be sine of x dx. So du is 1 dx, and v is negative cosine of x. So we get negative x cosine of x, that's u times v, minus the integral of v du. So it's minus the integral of negative cosine x dx. That's on the left-hand side. On the right-hand side, we get the integral of y dy. I'll address that one in a minute. So if you don't mind, I'm going to switch places on you a little bit. The integral of y dy is equal to, and we're going to get negative x cosine x. Minus a negative means plus, the integral of cosine x dx. And we are now ready to integrate. 1/2 y squared is negative x cosine x plus sine of x plus some constant c. Now, if you don't mind, I'm going to multiply through by 2. So y squared is negative 2x cosine x plus 2 sine of x plus k. And that's where k equals 2c. Okay? When x is 0, we know y is negative 1. Plug that in. So negative 1 squared is the same as negative 2 times 0 cosine of 0 plus 2 sine of 0 plus k. Well, sine of 0 is 0, right? So we know k equals 1. We're almost done. So y squared is, and then we get negative 2x cosine x plus 2 sine of x plus 1. And just like in the other problem, when we solve for y, we have to take negative the square root of negative 2x cosine x plus 2 sine of x plus 1. If we don't have that negative in front of the radical, the problem is it doesn't satisfy this initial condition of y of 0 equals negative 1. So you have to have that negative out in front of that radical. And this is the answer to problem number 20. And that'll conclude this video. This is section 9.3, and we worked on problems 13, 17, and 20. Okay, thank you.